Hello! In this episode of Finno-Greek Machining, it will be all about Heimer. Well, first of all, we are looking into a Heimer, then we are unpacking a Heimer, then we are adjusting a Heimer, and last but not least, how to use a Heimer. Well, let's go and do some Heimer. Well, okay. Well, here is the Heimer in its original package, original Verpackung. This is a German-made instrument for measuring. Yeah. Okay. So maybe most of you know what this is. Well, first of all, this is not exactly a cheap instrument. It's something like 400 euros. And but I think this will actually be worth all the money I have put into it. Well, yeah, let's see what's inside. First of all, we have some documentation, I believe. Let's see. Here is something. Well, wasserdicht. Well, you can read waterproof. And this is a testing certificate. And one important thing is that you have the serial number and the shank number here. Wow. Okay, let's see if those match with the instrument inside there. And then we have Bedienungsanleitung. There is also, I believe, an English version somewhere. Frankais, okay, French. That I don't really understand. I can read German quite well, but there is also an English version about this. Let's see if we need to reference that one later on. So, let's keep an eye what's inside. So, it's okay. Let's put that away. Then there is this styrofoam thing. Okay, it has. Okay. Again. And then we have this instrument which is actually quite heavy. It's not light at all. So 59330. 59330. So this certificate and that instrument are bound together. You can buy some Chinese stuff where you have a certificate, but it has no connection between the device you bought and with the certificate itself. It's just a copy or something. So now when we look here, so measuring deviation in 0 position, 1/1000th of a millimeter, and then repeated precision, they guarantee it to be 1/100th of a millimeter. Okay, half a tau about. So, and then we have this. Okay, and then we have one more thing. There isn't nothing much inside. You have an Allen wrench like that. It's a very special. It has long. It's a little bit special. Okay, so, and then we had this shank number. Which shank does it reference? The needle? No, I don't know. Oh, wow. I believe it's this, maybe. I don't know which shank they are referring to. Anyway, okay. So, This is a measuring instrument which you, okay, that way you can see the scale. This is a measuring instrument which measures the position of this ball here at the end. So if you turn it to the side, it's very stiff actually, you can see the meter moving like that. And if I move it to the other side, the meter is still moving. And back, actually in every direction it is moving. And furthermore, when both, you can see there are two arms here, and when those both are at 0, like that about, it means that the side of the ball is at the center of this axle. Yeah. Furthermore, you can measure depth with this one. So this is more like a relative thing, so that you it's measured like the Z. So the 3D comes from X, Y, Z. Okay. Well, there is, yeah, that's the instrument. And now the next I will show you how to set this up. You have to adjust it. It's not like adjusted. It's not guaranteed that this ball here is at the center of the shaft. So it must be adjusted first. Okay, yeah, you can actually screw this out, I believe. Yeah, you can. This is a very delicate thing. You shouldn't stumble it anywhere. So this is a precision thing, this. And yeah, it's really important to keep it from bending or anything like that. Well, yeah. Okay, so next step will be to adjust this. So let's go on with that one. Well, here are some well, tools, so to say, to set up, to adjust this Heimer. First of all, we have the Heimer itself. Then we have the adjusting wrench, which came with the Heimer. And then we have a collet. This is ER40 20 millimeters ER collet. This is because the shank is 20 millimeters in this case. And I have cleaned this up pretty much clinically. So it's really, really clean. You can hear it. There is absolutely nothing in between there. And also this, when I installed it into the milling head, the holder, it is also very, very clean. So, and then we have this measuring instrument here. This is actually a dial indicator with resolution of 1/1000th of a millimeter. Yeah, 1/1000th of a millimeter. So every line here, which are pretty fine, in a way, presents 1/1000th of a millimeter movement there. And well, but you can easily adjust it with that one, I believe. Okay. So next I will show you how to do this. Well, okay, here we are now. Now this indicator here is leaning against the ball of this Heimer, and it's really touching it. Yeah, you can see. And then I have put this into free gear so I can rotate it, and you can see right away that it's a few hundreds out of, well, around. So we need to take care of that. So the first thing to do is to loosen. Here are some screws inside here. Yeah. So you have to loosen all of them, all 4 of them. That's important to do. Just loosen them. This is like a 4-jaw chuck, it has 4 of these. Yeah, so they are counteracting set screws there. Let's see, okay, they are now loose. And this looks like we have 600ths of a millimeter. So we should get this one, for example, around 300. So let's see if this moves a little bit lighter now, because it was really like it had, well, it still has these sticks in. Oh, no, this is more like that. Now, okay, I moved it 300 in this direction. And well, what do you see? There you are. Is it really there? Ha! Well, that was easy fix. Now I just have to tighten these all. Well, that was tight. Well, why it was so easy was that I found out what is the lowest spot here, and then I measured the total deviation, and then I found out the maximum, and then I adjusted it to the halfway. And there you are. And now we have to tighten these properly so that they don't. Okay, this was totally loose. I'm looking at the needle all the time so that it doesn't start to move. Okay. It was quite tight actually when I adjusted this, so it was really. Oh yeah, okay. Normally you do need to do this only once. So, okay. Well, it's quite safe to say that it's inside 1/100th of a millimeter. Well, it's I can see deviation of 2/1000s, but if you put force into this, you can see that I can wiggle it, but this really needs some force. And it is because of the flex of this. I can actually do the same by moving the table. This is very sensitive instrument, so well, it's really measuring. And since the bearings are up here somewhere, and there is a very long way from the ball to the bearings. So the bearings, well, they have some. They are not exactly tight. Well, this is an old machine. It's really, even though they are a little bit loose, it still has some tendency to warm up the bearings. Yeah, okay. This is, well, to my accuracies, what I need, my tolerances, this is totally all right. Okay, now that we have adjusted this Heimer, it's time to use it. Well, what do you use it for? Well, you can see there is this little ball here under, and then we have those scales, those arms here moving. When I push it, they move. And when the both arms are at 0, so at that point the side of the ball is on the center of the axis of z-axis of this one. So let's now put a workpiece here. This is some tool steel. It has some decent surfaces. Let's adjust this with this one. So I put it there. Well, and now I need to, I can put it a little bit on the side so I can demonstrate one more thing about this. So it's there now. not very tightly, but tight enough for our purpose. So let's move the table so that we can okay, now the ball is at the side of this workpiece. Now if I move the y-axis here, you can see that the needles start moving. I'm moving the table this way. So you can see they are moving now. And now at this point, the y-axis is at the axis is at the edge of this workpiece, this moment. Yeah, one more thing about this, you shouldn't be rotating it like that when you measure. Why is this? Well, let me drag this a little bit. You can see it has impact on the needle when I drag it. And furthermore, this also has well, okay. So anyway, when you measure, you should place it in some suitable position, and then do your adjustment like this. There you are, and then you can also do it for the other axis. Go here and do the same thing with the X. Now I'm dragging the table this way. And you can do the same way here. Now. And when I now go back to 0 with this dial here, which I zeroed, like that, we are exactly on the edge, on the corner of this workpiece. Yeah, okay. Well, there are some things, this is pretty straightforward. You can probe the edges of straight surfaces like this. Well, what if the object is not, what if it is not like a square? What if the object is round like this? This is a 10mm pin. And you can also, in this case, now it's there, the pin is there. There are a few, because I now know the diameter of this, it's pretty easy to find the center of this one. Just measure the side. Well, not that simple, because you need to be in the middle of the exactly at the middle of of the shaft when you do this kind of measurement. If I now drag it up and down, okay, here you can find the maximum quite easily. There you are. And now you can actually have it like this. And now it's at the level, or at the axis is now aligned with the side of this thing. So now we are at the edge, but if we want now to be in the center, I move it here, and then I move this 5mm. Yeah, now it's correct direction. That was 4 and 5. Now it's in the exact center of this pin. So let's see whether our scale matches. I put it 5 more. So that's now 8, 9 and 10. Now we are at the other side of this. So because this was a 10mm pin. Let's see if it... Yeah. Oh. Well, 2/100 of a millimeter deviation here. Not much. Yeah. And what more? Let's see. Well, the round objects are not always oriented like this. They can be. Are you still in the frame? Yes, you are. They can sit like this. Let's put it there, like that. And now you want to have it centered with that one. Well, it's pretty much the same procedure. Okay, you move it here. Find the maximum here. There. And then you just go to the edge of that. That's in the edge. It's very accurately on the center. And now, this kind of operation cannot be done with this. This is good for aligning with straight surfaces or round surfaces, but only this way. You cannot do it this way. This would be very hard to do because it's hard to do because you cannot. This is an edge finder. It finds an edge, but it doesn't give you any clue how far you are from the edge. For example, finding the center point from here. Well, it's impossible, not impossible, but very hard with this one. This is the normal center finder, edge finder I've been using. Well, now, now I'm going to be using this one. You can roughly, but very roughly actually, set up the, for example, we have this here, and now I want to drill a hole into the middle of that one. Well, you can do it like this, but be warned, this is not the most accurate way of doing this. Okay, there you are. It should now, when I move my Z like this, I want to have it somewhere. I look for the maximum here. There. Now it's pointing at the exact middle of this workpiece. Well, it's a little bit loose. So yeah, not in the exact, but very near of that. If you want to get it more accurate, you have to measure it from the sides. Then you get it really accurate. But for the most, if you don't need, well, this is, I think, well within 500s. But if you want to get the last hundreds of a millimeter out from that, you have to measure it from the sides. Okay. And yeah, then there is a sticker that you can attach to your milling machine. So and so many days since I crashed my Heimer pin. Oh yeah. And well, it's this is very easy to crash. So especially in CNC machines, this is easy to crash. In manual machines, it's well, it's not that prone for making your life miserable. Yeah, okay. So that's about how to use a Heimer. And how to adjust it and what is a Heimer. Okay, hope you learned something from here. Well, it's an expensive instrument, that it is, and well, it's but I believe it's a game changer. Is there already? No. Aha, there is a, you can change the bevel, it's plastic. Just by, there is a ring going around here which you remove and then the plastic comes out and then you can put in a new one. This is also good because you can buy new tips for this one. You can buy longer version for this one so that it's longer. And then having this in an ER collet is probably not the best possible solution. I will actually have a separate ISO 30 collet for this one. Well, there were devices which already had this ISO 30 taper here, but they were of different generation. They were marked as new generation, and you couldn't see anywhere written made in Germany. So chances are that those are not made in Germany, because they certainly would put that text into there if they were made in Germany. So this is the reason why I bought this with this shank. Okay, so that's it. Yeah, well, here is the Heimer, and well, I hope I can make a lot of use of it. Well, you might wonder why I spend so much money on a measuring instrument like this. Well, there is a very good reason for that, and this is going to minimize some of the errors I usually make with this edge finder. You always have to do some math with that one, and my computer is not that fresh. it really makes mistakes dividing 6 millimeters by 2, adding this to something, and yeah. This one removes one element from that equation, and it's actually it removes more than one. Well, but nevertheless, it's a very good instrument. I believe I have a lot of use for that one. Yeah, you will see it in action in the future. So in the next episode of Finno-Ugric Machining, we have two choices. One, either finish this drill sharpening jig, which is total overkill really, or we can make two inlet and outlet ports for that rotating vane compressor. Now that we have the Heimer, this should be a little bit easier to do. Well, yeah, it's well, let's say it will be the input and output ports for that thing, so we can finally start up making a little bit of tests, and hopefully also I receive my liquid gasket. It will be Loctite stuff, which is I believe it was Loctite 150. Something like that, but it's an anaerobic thing that when you put it between two surfaces, it will act like a thread lock, but it makes a gasket. And then the rest, which is flowing around, will can be wiped away. It's oil soluble at that point, so it shouldn't cause any trouble after I put the thing together. So, and then I need a shaft sealing, which I still don't have. It's also coming. So, yeah. So, till then, bye!